This is Terrafab, a $25 billion factory that produces absolutely nothing you can touch. No steel, no components, no physical goods. The only thing born here is pure artificial intelligence. Tesla is betting its entire future on shattering the dominance of the world's chip giants. Why take such a massive risk? The answer lies right inside these doors. Sector 1, Raw Material and Silicon Entry. As the doors to the first sector open, the first thing that hits you isn't sound, it's an eerie silence. We are entering the sanctuary of 9N, where silicon reaches a purity of 99.9999999%. Let me help you visualize that. If this silicon wafer were a road stretching from New York to Los Angeles, a single speck of dust would only be allowed to be the size of a grain of sand. Why is Tesla obsessed with this purity? Because at the 2-nanometer process, we are no longer working with mechanics. We are dancing with individual atoms. At this scale, a stray organic molecule, a dead skin cell or a microscopic fiber, becomes a giant meteor crashing into the circuitry. Tesla doesn't just buy 300mm wafers from suppliers like an ordinary customer. They are reaching deep into the supply chain, controlling how silicon atoms are arranged from the very start. Why? Because if the substrate isn't perfect, every effort thereafter is meaningless. You cannot build a crystal palace on a cracked foundation. At Terrafab, perfection isn't a distant goal. It is the only passport that grants you entry into the 2-nanometer world. Sector 2, the EUV Cathedral. Crossing the preparation area, you enter the clean room, where hospital sterility standards become obsolete. This is the domain of the ASML TWINSCAN XC High-NA machines. Look at them. Each machine is a marvel worth over $200 million, more expensive than a luxury private jet. And it is the only thing on the planet capable of printing Tesla's future. Extreme ultraviolet light isn't just normal light. It is a form of energy so strange and fragile that air itself can swallow it. Therefore, the entire lithography process must occur in a vacuum as absolute as deep space. But here is the real turning point. Gate-all-around transistors. Forget the old architecture. With GAA, Tesla is crafting electromagnetic valves sealed on all sides. If the old transistors were a leaking faucet, GAA is a hermetically sealed system. Why does Tesla crave this? Because Terrafab is projected to consume 2 gigawatts of power, enough energy to light up an entire city. In a game of extinction-level scale, saving 30% of power via 2-nanometer chips isn't just a line on a financial report. It is the line between a sustainable autonomous empire and a power-hungry monster that collapses under its own weight. Sector 3, AI5 and Dojo. Deep inside the design core, you see Elon Musk's true philosophy. The best part is no part. While Intel or Nvidia must design chips to run Excel, play games, and process graphics simultaneously, a jack of all trades, master of none, Tesla does the exact opposite. Welcome to the kingdom of the AI5 chip and Dojo D1. These beasts weren't born for versatility. They were born for one thing: performing matrix multiplications at the speed of light. Tesla has aggressively stripped away decades of junk code and legacy architectures that slow down AI inference. The result? A brain that is lean, cold, and hyper-efficient. If an Nvidia chip is a Swiss Army knife, Tesla's AI5 is a samurai sword, single-edged, but sharp enough to slice through any data barrier. This isn't just Apple-style vertical integration. This is hyper-integration. Tesla is hand-casting the soul for millions of robotaxis and billions of Optimus robots. They don't buy intelligence, they manufacture it right here in Austin. Sector 4, 3D Fabric. Leaving the lithography zone, we enter a space where chips no longer exist as lonely islands. Welcome to the era of chiplets and 3D fabric technology. Why are we here? Because Moore's law is dying, and trying to cram more transistors onto a flat plane has hit physical limits. Tesla's answer: stacking. Imagine the AI processors and memory layers no longer sitting side by side on a circuit board, connected by slow, country roads. At Terrafab, they are bonded directly on top of each other, creating a high-speed elevator for data. With internal bandwidth reaching a staggering 36 to 50 terabytes per second, Tesla has officially killed the bottleneck. To put it simply, you could transfer the entire global Netflix library between chip cores in less than a blink. This isn't just an upgrade, it's a structural revolution. While legacy systems waste most of their time waiting for data to move from memory to the brain, at Terrafab, data is instantaneous. Sector 5, the AI training pipeline. If you are looking for an exit for physical products at Terrafab, you will be disappointed. This factory doesn't ship anything you can hold. Its final product is invisible yet all-powerful: evolution. Here, Tesla operates a perpetual loop. Every week, The system consumes roughly 70,000 GPU hours to digest billions of video frames from the real world. The result? Every passing week, the FSD software becomes one level smarter. It doesn't just learn to drive, it learns to understand the world. The most important metric here isn't horsepower, it's latency. Tesla has successfully slashed response latency by half. In the world of self-driving, 10 milliseconds isn't just a spec, it's the line between life and death. Terrafab doesn't sell chips, it sells reflexes that far exceed human capability. Sector 6. Networking. To keep hundreds of thousands of GPUs from becoming a chaotic mob, they need a central nervous system. That is where NVIDIA Spectrum X and Tesla's custom InfiniBand protocols come in. There is a harsh rule in computing called Amdahl's law. As you add more processors, the incremental efficiency decreases due to communication overhead. Tesla is defying this law with a network efficiency of up to 95%. Compare this. Typical data centers waste up to 40% of their energy just letting chips talk and wait for data. At Terrafab, that waste is nearly eliminated. Hundreds of thousands of cores operate in perfect sync, like a single entity, a massive brain spanning rows of racks. This isn't a computer network, it's a digital nervous system optimized for one purpose, the creation of intelligence. Sector 7. Thermodynamics. The deeper we go, the roar of the cooling systems becomes more intense. This is where you realize, the greatest challenge to AI isn't algorithms, it's thermodynamics. Every second, Terrafab consumes power equivalent to a small city, about 2 gigawatts. Without a solution, this heat would melt everything. Tesla has scrapped outdated fans and replaced them with liquid-to-chip cooling. Coolant is piped directly against the silicon surface to suck away every joule of heat the moment it's generated. But Tesla doesn't stop there. They apply circular economics to heat. 13 million gallons of water are recycled daily, and the waste heat from the supercomputers isn't vented away. It is being researched to heat buildings or provide thermal energy for steel stamping at the nearby Giga Texas. Terrafab is a biomechanical entity that utilizes every scrap of energy to survive. Sector 8. The final product. Why does Tesla need to own this entire massive supply chain? The answer is Optimus. For a humanoid robot to replace manual labor, it must be cheap. You cannot put a $40,000 brain into a machine you intend to sell for $20,000. Terrafab is the solution. By manufacturing chips at a scale of millions, Tesla can crush the cost of an AI brain from impossible down to a few $dozen. Terrafab is the mother of every future Tesla product. From the steering wheel-less cybercab to armies of Optimus robots, all are born from algorithms refined here. Tesla isn't just building a factory, they are building the machine that builds the machines. How valuable is the product that the Terrafab factory actually creates? The true product of the Terrafab is not just silicon, but the industrialization of intelligence. To understand the significance of this output, one must look at the AI5 chip, which acts as the physiological heart for the next generation of Tesla's autonomy. In the world of high-end computing, most processors are designed to be general purpose, balancing graphics, rendering with complex mathematical operations. However, Tesla has abandoned this jack-of-all-trades philosophy. By utilizing a cutting-edge 3-nanometer process for initial runs and a 2-nanometer process for volume production, the AI5 delivers approximately 8 times the compute power and 5 times the bandwidth of its predecessor, AI4. It is built as a specialized samurai sword that ignores traditional graphics tasks to focus exclusively on matrix multiplications. This singular focus allows a single AI5 SoC to rival the inference performance of an NVIDIA H100, while a dual-chip configuration matches the NVIDIA Blackwell architecture. Crucially, it does so while operating at a mere fraction of the 700-watt TDP typical of high-end GPUs. This extreme efficiency is the only way a vehicle like the Cybercab or a robot like the Optimus Gen 3 can process massive streams of visual data, reaching 2,500 TOPS of performance, without draining its battery or requiring a massive liquid-cooled server rack on board. As we look deeper into the factory's pipeline, the roadmap extends into the AI6 and AI6.5 series, which represent Tesla's push to the absolute physical limits of semiconductor technology. The AI6 is engineered to double the performance of AI5 by integrating LPDDR6 memory and a 2-nanometer gate-all-around process, ensuring that data moves as fast as the processor can think. The most strategic revelation, however, is the AI6.5, produced in collaboration with Samsung and TSMC. This is the first chip designed specifically to allow humanoid robots to operate in a 24/7 industrial cycle, by moving to a full 2-nanometer process. Tesla achieves a level of thermal efficiency where the Optimus robot can perform high-intensity labor without the risk of overheating. This creates a functional bridge between digital AI that lives in a cloud and physical AI that can safely and tirelessly inhabit our physical world, supported by a production capacity aimed at 40,000 wafers per month. Parallel to these mobile brains is the production of the Dojo 3 training tiles. These are the massive, invisible products of the Terrafab that reside in supercomputer clusters rather than inside cars. Dojo 3 is the infrastructure that allows Tesla to reach the exaflop scale, the ability to perform a quintillion calculations per second. Each Dojo D1 chip already packs 354 independent processors and 440 megabytes of SRAM. But Dojo 3 scales this exponentially. By adopting a system-on-wafer design, Tesla has effectively eliminated the latency bottleneck that plagues traditional data centers, reducing energy per transmitted byte by up to 38%. Instead of data crawling through slow copper wires between individual chips, it flows instantaneously at bandwidths reaching 36 to 50 terabytes per second across a single, continuous wafer. This allows Tesla to train its FSD models, digesting billions of miles of real-world video in a matter of hours, creating a feedback loop of evolution that no competitor can keep pace with. The most profound value of these products, however, lies in their impact on Tesla's profit margins and global accessibility. Currently, the industry is beholden to a silicon tax where a single NVIDIA H100 or B200 can cost between $30,000 and $45,000. By controlling the entire manufacturing stack within the $25 billion Terrafab, Tesla brings the internal cost of these same units down to a few hundred or $1,000. This vertical integration is the secret sauce that transforms the robotaxi and Optimus from luxury prototypes into affordable consumer products. When the brain of a robot costs $500 instead of $50,000, the path to a $20,000 humanoid worker becomes a mathematical certainty rather than a marketing dream. Finally, the Terrafab's influence extends beyond our atmosphere through space-grade AI. In collaboration with SpaceX, the factory produces radiation-hardened chips capable of surviving the harsh environment of orbit and deep space. These chips turn the Starlink satellite constellation into a giant, orbiting supercomputer, with prototype 100-kilowatt AI mini-sats designed to process Earth observation data or interplanetary communications on the fly. Whether it is a car navigating a busy street in Austin, a robot working in a factory, or a satellite orbiting Mars, the products of the Terrafab represent a unified nervous system for a multiplanetary civilization. Tesla is no longer just a car company. It has become an industrial refinery for the fundamental currency of the 21st century: autonomous intelligence.